Number 4 asks, which of the marked lone pairs on the following compound is delocalized? So what this is asking is there any lone pair on here such that we could draw another resonance structure by turning that lone pair into a covalent bond, pushing some other pi electron density onto some other portion of the molecule? Which one of these lone pairs can be moved around, essentially? So let's look at number 1 first. We have an oxygen. We have 2 lone pairs there. Is there anywhere that these can go? Can we, for example, take this lone pair and put it right there? Well, we can't here because this carbon already has 4 bonds. It's got a bond to oxygen, 2 bonds to these 2 carbon atoms. There's an implied hydrogen. It is not going to be able to accommodate any other bonds. We need access to other pi electrons that can shuffle around in some other way. We have a pi bond over here, but that's just too far away. It's not going to be able to interact with this one, so that's going to be no. Let's look at number 2. We have a lone pair here. Is it the case that this can go down here? Well, in this case, it actually can, because this is adjacent to this pi bond. This CN sigma bond is adjacent to this CC double bond, which has a sigma and a pi bond. So if we push this lone pair down like that, we can also take this pi bond and push it right there, and we could put the anion on that carbon instead. We would end up with N plus and C minus. This is the case that this lone pair is delocalized. That is going to be number 2. Let's just look at the other options. With the fluorine atom, we've got 3 lone pairs here. Is it the case that we can take a lone pair and push it there? Well, no, we can't, because again, we've got a carbon atom here that's got 4 bonds already. It's not going to be able to accommodate another bond because it cannot lose a bond the way that this carbon atom did, right? This carbon atom was able to accommodate a new bond because it was able to lose a bond as well and remain coordinated with 4 bonds there. So this one can't do it. That's no good. And then the same thing here with oxygen. This just isn't going to work. This oxygen could take one of these pi bonds, but we're not going to form yet another bond here because this carbon has no bond that it can lose. So this also is not going to work. Again, in order for the lone pair to be delocalized, we have to be able to draw another resonance structure like we did here, where this lone pair goes down, we form a pi bond there, and then we lose that pi bond that flies up and gives you the anion on the carbon atom. So that one is going to be B, lone pair number 2.